Hi, welcome to this video. Today we will be comparing the time the same optimization algorithm in the same computer spends training a neural network with Scikit-learn and with Neural Designer. We will also study the linear regression analysis made with the testing samples and compare the correlation obtained. Finally, we will see the principal differences between both machine learning platforms in terms of usability, functionality and performance. We start the study with Scikit-learn. First, we import these two libraries, Pandas and Pylab. Pandas is a library that allows us to read data from a CSV file and manipulate it. Pylab let us generate plots. We import standard scalar from Scikit-learn to scale the data to have a variance equal to 1. On the other hand, we import MLP regressor. This model optimizes the squared laws using quasi-Newton or stochastic gradient descent. Finally, we import train test split to separate the data into testing and training, R2 score to calculate the correlation between predicted and real values, and time to count the time the algorithm spends loading the data, training and testing the neural network. We have divided this exercise into 4 parts: loading, scaling, training and testing. In this video, we're explaining each of them. The first step in the loading part is to initialize the time. It's like setting the counter to 0. Then we select the data from the file we want. In this case, we are modeling the power plant gas emission example, which we can find on the Neural Designer examples website. The next step is to read the data from the file. Once the program ends this task, we calculate the loading time by subtracting the initialize to the actual time. The first step in the scale part is to save the inputs and the target using ilog. This function enables us to select particular cells of the dataset. Then, we use values to subtract just the values from the data in the previous variables. To manipulate the data correctly from the one-row array, we need to reshape it to a one-column array. Then, we rename the library standard scalar to scalar. And finally, we scale the data with the method fitTransform, which returns a transformed and scaled version of the data, X data and Y data. The first step in the training part is to divide the samples into testing and training. In this case, we split it into 75% training and 25% testing by using the train test split method. This allows us to save into 4 different arrays, train and test inputs, and target data. Then we call the MLP regressor with some random parameters: 12 neurons, the hyperbolic tangent as the activation function for the hidden layer, the parameter alpha equal to 0.01, which is the L2 regularization weight, Adam optimization with a maximum number of iterations of 1000, a negative tolerance of the solver to complete all the iterations, and the variable verbose must be true to print some progress messages. Then, we initialize the time and train the model using the method fit with the arrays xtrain and ytrain. Finally, we calculate the training time. The testing part starts initializing the testing time. Then, we use the method predict to predict the target values and calculate the predicting or testing time. The next step is to scale the data to show the plots in the correct units. We use the function inverse transform to scale back the data to the original representation. Finally, we calculate the correlation between the real values and the data predicted using the trained model. Now we can run this program and see in the Python console real-time progress. Once the program is executed correctly, we can see the training time, the testing time, and the graph correlation. We continue with the machine learning platform Neural Designer. First of all, we need to browse the data file. Then, as there are two targets, we get rid of one of them. In this case, we set as unused the target corresponding to the CO, or carbon monoxide, emissions. The next step is to divide the data into testing and training. We have chosen, as in the Scikit-learn example, 75% training and 25% testing. In the neural network tab, we set the hyperbolic tangent as the activation function and 12 neurons, the same as in the Scikit-learn example. In the training strategy tab, we select the normalized squared error with altitude regularization and a weight of 0.01. As the optimization algorithm, we choose Adam with 1000 epochs and a training loss goal of 0. The next step is to perform training. Once the training is done, we obtain the elapsed time and the training error. We perform a linear regression analysis with a model already trained to determine the correlation between the real and the predicted values. To sum up, we can see certain advantages from one platform to the other one. Neural Designer is a code-free machine learning platform. It allows us to create a neural network easily. Even you don't have to worry about the scaling or the unscaling part. It let us also change the scaler simply by selecting the method we want to proceed by a drop-down menu. In Scikit-learn, we have to change almost everything corresponding to the scaling part. Also, we can easily see the data we are importing from the CSV file. Regarding the variables here, we can remove any, setting them as unused. Regarding the instance, we can split the samples into training and testing by choosing a particular percentage. Finally, by clicking on the Task Manager tab, we can perform training, a linear regression analysis, calculate specific errors, and even a model selection analysis. Given these points, I would like to remark that we have spent much more time coding in Python with the library Scikit-learn than changing the specific parameters in Neural Designer.